Before we go through logical connective, we must understand first the concept of logic. Logic is a science of thinking and reasoning correctly. It helps us to understand, analyze, and test the hypothesis. We use concept of logic to make a conclusion of a statement. So, what is a statement? A statement is a declarative sentences that can be true or can be false, but it is impossible to be both. Statements are also called a proposition, but remember, only a declarative sentences can be a statement. Other sentences cannot be a statement. For example, questions, instruction, or exclamatory sentences. In logical connective, we have two types of statements. The first one is a primitive statement. Primitive statements is a basic of statements. It consists of declarative sentences and a simple one. And the second one is called compound statement. A compound statement is a declarative sentences and contain a logical connective. We have 5 logical connective: negation, conjunction, disjunction, conditional or implication, and biconditional.
First up is the simplest one, negation, or simply not. Let's say the first statement P is I want latte. If you apply negation, it becomes I do not want latte. Negation is a truth flipper. If the original statement is true, then the negation makes it false. If the original statement is false, then the negation makes it true. Simple as that. Next is conjunction, or a logical word for and. Let's bring in the second statement Q, I want to read books. If you use conjunction, it becomes I want to read books and I want latte. Well, here's the catch. The only way for this entire sentence to be true if you get both parts. If you only get a book, but you don't get latte, then it will be false. Third is disjunction, which means or. So it becomes I want to get latte or I want to read books. This sentence is perfectly true even if I ended up getting a latte or I read books. And it is also perfectly fine if I ended up doing both. I get a latte and also I read books. So for the only way for a disjunction sentence to become false is if I ended up not doing both, which is I do not get latte and I do not read books. Now we enter the territory of promises, conditional statements, implications, or if-then. So if R implies P, it is to be said that if I get a bonus at work, then I will get a latte.
I'm light skinny demons that I know what they need headed. That's right, cause they'll fake a ticket man and you made them R's up and R's.
And this is where logic becomes tricky. For a conditional statement to become false, it is only to be said if the condition happens but the outcome doesn't. So, if I get a bonus, then I do not get a latte, then it will be false. Finally, we have biconditional, which represented by a two-way arrow, or it means if and only if. So, P if and only if S means I want a latte if and only if I am studying. This simultaneously means two things, which is if I am studying, I 100% want a latte, or if I want a latte, then I am 100% studying. For a biconditional statement to become true, it is only if both statements have the same truth value, either both are true or both are false.
If cafe open, then Alia buy latte. If cafe close, and Alia does not buy latte. If Alia buy latte, then Alia happy. Alia does not buy latte. Next is the truth table for our argument. This table shows all possible values for all P, Q, and R together with the premises and conclusion. We focus on the rows where P1, P2, and P3 are all true because the argument is P1 and P2 and P3 implies Q. When all the premises are true, we check Q. If Q is true, then the implication is true. However, if P1, P2, and P3 are all true, but Q is false, then the implication becomes false. Therefore, our argument is valid because it is tautology. If Anna joins debate club, then Anna improves communication skills. Anna joins debate club, or Anna not confident in class. Anna improve her communication skills if and only if Anna confident in class. Conclusion: Anna improved her communication skills. We created a truth table based on our premises and assigned the truth value for each statement. Based on the truth value, we can compare the first row and the last row. In the first row, all the premises P1 and P2 and P3 are true, and the conclusion Q is also true. This happened because in an implication, when the premise is true and the conclusion is true, the statement will remain true. However, in the last row, all the premises P1 and P2 and P3 are true, but the conclusion is false. According to the implication rule, when the true premises leads to a false conclusion, the whole statement becomes false. Therefore, our final conclusion is false in this case. Since the statement does not produce true result for all cases, it is not a tautology and the argument is considered invalid.
If Amira uses library, then Amira understand better. Amira understand better and Amira performs well in exam. If Amira does not use library, then Amira does not understand better. Conclusion: Amira performs well in exam. We constructed a truth table to determine the conclusion by analyzing different truth values. For this example, it concludes that this argument is valid because for every hypothesis which is true, it implies to an also true conclusion.
If Ashraf attends extra tutorial class, then he asks a question. Ashraf does not attend extra tutorial class. If Ashraf does not attend extra tutorial class, then Ashraf does not score highly in tests. The conclusion is Ashraf does not score highly in tests. We use the truth table to analyze if the argument is valid or not by looking at the truth values of all premises implies to the conclusion. If it is a tautology, then the argument is valid. From this truth table, the truth value of P1 and P2 and P3 implies Q are all true, which is a tautology. Therefore, the arguments are valid.
To conclude, logical connectives are like tools that help us connect ideas and also can check whether the statements are true or false. They make logical thinking more easier in many areas, from studying to everyday decision making. We hope this presentation helped you in understand logical connective better. Thank you for watching.